I want to briefly talk about the concept of odds. By definition, the odds in favor of an event E is given by the probability that E occurs divided by the probability that E does not occur. But I find that a more useful way to think about it is this. If we think of two numbers m and n, where m is the number of ways to get what you want from the sample space, then n, of course, would be the number of ways that you don't get what you want from the sample space, making the sum m plus n the total number of items in the sample space. Then the probability that E occurs is m over the quantity m plus n. All I'm saying here is that m is the number of things you want divided by the total number of things in the sample space, and that is basically the basic probability principle that we've already discussed. But if you break it up this way, it applies to this idea of odds. M then becomes the number of ways to get what you want, and n is the number of ways to get the things that you don't want. I think it's a much better way to think about it, and I'll show you with an example. Suppose I draw a marble at random from a box that has 2 yellow, 5 white, and 6 blue marbles. That's a total of 13 marbles in the box. I'm going to answer two questions, or ask and answer two questions about this. The first question is, what is the probability of drawing a yellow marble? Now this is something we've dealt with, and I don't think you'll have any trouble with it, but the probability of getting 2 yellow marbles would simply, by the basic probability principle, be the number of ways of getting what you want, the 2 yellows, over the number of ways to get any marble, which would be one of those 13. So the probability of getting 2 yellows by the basic probability principle would be 2/13. And we've dealt with this before. The second question is the one that I really want to focus on. And before I do that, let me just say again that if you break the sample space into two parts, one of which you count m things that you want, and the rest of them count to n, and you might describe those as the things you don't want. Then if you group everything together, you get what I call the whole, and the whole is just m plus n. It's everything in the sample space. So if you think about this, before you get to this next question, I think it'll be easier. And the next question is, what are the odds of drawing a yellow marble? Well, once you break the sample space up into two pieces, one piece being what you want, there are m of those things, and n being the things you don't want, then the sample space would have n plus n elements in it. Remember, odds are m to n. Well, so in this case we have 13 things, so the whole is 13. So you have 13 marbles, and if you break them into what you want and what you don't want, if you're looking for a yellow, then the rest of the things would amount to 11. Those are the things that are not yellow. And are the things that you don't want. So according to this, the things you want are represented by m, and the things that you don't want are represented by n. And the odds are m to n. And like I said earlier, you can write it with a colon, or you can actually write the word 2, or you can write it as a fraction, m over n. But I'll write it m colon n. And that would be, in this case, 2 to 11. It's the things you want to the things you don't want. So this idea of breaking the sample space up into what you want versus what you don't want, to me, is very powerful. I would also note, just for completeness, that sometimes they ask for the odds against something, and I never make much of that. The odds against are just the reciprocal of the odds for in favor of something. So if they ask me for something where they ask for the odds against, I just go ahead and do the odds in favor, and then when I finish, I note that against is just the reciprocal, so it would be reversing these two. So if I actually ask you the odds against getting a yellow, it would simply be 11 to 2. Okay, let's do another one. In this problem, I know that a player will make, the probability that a player will make a certain shot is 0.55, and I want to know what the odds are against the player making the shot. So first of all, I'm looking for odds against. I'm not going to worry too much about that yet. I'm just going to go ahead and do the odds in favor of, and then I'll just take the reciprocal. The main thing I'm worried about is the trick that I used before, involving m being the things I want versus n being the things I don't want. That little, for the lack of a better term, trick with the whole sample space being m plus n, if you take both of them together, depended on me using a fraction and looking at the fraction. Well, that's not hard here, because 0.55 is 55/100ths, which reduces by 5 top and bottom to 11 over 20. So even though it started out as a decimal, I converted it to a fraction. So the odds in favor of the player making that shot is given by the number of ways to get what you want, which would be 11. Remember that the numerator is the m, and if you have to think about this, be explicit. M is the numerator, so that would be 11 to n. The odds are m to n. Remember, m to n. But what is n? Well, the total is 20, and n is what it takes added to m to get 20. So if m is 11, n must be 9. So the answer for the odds in favor would be 11 to 9. But remember, the problem asked for the odds against. So the odds against that player making the shot would be the reciprocal, putting the 9 first, 9 to 11. And that's the actual answer to the problem for odds against. Now just remember, I could turn that back into a probability very easily by taking the 9 to be the numerator for the odds against, and 9 plus 11, which is 20, as the denominator, and it'd be back to a probability again. And if you haven't figured it out yet, I'm trying to tell you that there's a big idea here, and that big idea is that, same thing I've said several times, if you let m be the number of things you want from the sample space and let n be the rest of them, namely the things you don't want, then if you add them up you get the entire sample space, and that's what I call the whole. If you're doing a probability, always going to be part to whole. It's the part you want to the whole. But when you're doing odds, it's going to be part to part, and it's the part you want to the part you don't want. So the big idea is what I'm trying to get across here. When you're doing probabilities, it's always part to whole. It's the part you want over the whole, everything in the sample space. Whereas when you're doing odds, it's always part to part, and it's the part you want to the part you don't want.